Hi everybody, this is Dr. Bardo, and I want to share with you a little bit today about parametric equations. These can be used to create graphs that have a defined beginning and start. So what you see here is a grapher page, and it's set up just with its default, and it says y equals, which is how we think of graphing most things. We're going to take a different approach today. Instead of telling it what y equals, we're going to tell it what x and what y equals. So we're going to use this matrix. And this is sort of the heart of the idea of parametric equations. And so I'll need to have, so x and y is going to be over here, so I'm telling it what it's equal. And then on this side, I'm going to give it the formula. So I'll have a formula for x and a formula for y. But, and what I'm going to do is use a separate variable. This variable is called the parameter. And I'm going to tell it exactly what numbers that parameter can equal. So in this case, it's saying that the parameter can equal 0 to 1. And in the formulas I've written here, I've said that x is equal to t and that y is equal to t, which means that x and y must be equal. So take a minute and think about what that graph's going to look like. Knowing that x and y are going to be equal, t is not going to be expressed per se on this graph. And so you see we get a piece of the graph y equals x. But we don't get all of the graph, we just get the stuff that starts at 0, 0 and ends at 1, 1. That's because I've made t go from 0 to 1. If I change what t goes to, if it goes from 0 to 2, then my graph is going to be a little longer. If I wanted to get a different line, if I wanted a different slope, one that had a slope of 2, then I would have my y be 2 times my x, and my x is equal to t. So 2 times x is equivalent to 2 times t, and now I've got a line that's 2 times as long. And my x goes from 0 to 2, and my y goes from 0 to 4. What about a parabola? Well, in a parabola, the standard parabola is y equals x squared. And since x is equal to t, I can say that y is equal to x squared by saying that y is equal to t squared. And I'll change this back to 0, 1. And again, now I get a nice little piece of a parabola that goes from 0, 0 to 1, 1. But it's only half the parabola. What if I want the other half? Well, then I'll let my t go from negative 1 to 1. And I get both halves. One nice thing that's easy to do with a parametric equation is to shift it. So if I want to shift it, move it over, I'm just going to add on to my matrices. And the way the matrix multiplication, matrix addition works is to just add component-wise. So this addition here is going to be move it over 2 and up 3. So, zoom out a little bit. So we see it here. It's been moved over 2 and up 3. If I change this to a negative 1, then it's going to be over 2 and down 1. This is the same, by the way. You don't have to have this other matrix. It's just the same as putting a plus 2 here and a minus 1 there. So it gives me the same graph. But I like separating it out into the separate one because it makes it sort of easier to understand. So I'm going to have a matrix that does the shape. This would be my shape matrix, and then I would have another matrix here that would be my kind of move matrix, my translate matrix, and that just makes it a little bit easier for me to understand what's going on. All right, so we've seen lines, we've seen parabolas. What about circles, ellipses, hyperbolas? Well, those actually require a little bit more. Some functions that we haven't dealt with in Algebra 2, but I'm just going to show them to you, and I think you'll understand them pretty well enough to make graphs with. So if I would like to do a circle, I'm going to use cosine and sine. So these are functions that you learn about in trigonometry, and they're based on the circle, and they're based on a particular way of measuring the circle called radians, and radians go from full circle of radians goes to 2 pi. If I want to make pi in grapher, I just hit P and then I, and it turns it into pi. So if I graph this, I'm going to get a nice unit circle. I'm going to zoom in a little bit. So there's a nice unit circle, and if I would like to make half a circle, Then I'm not going to use a full circle's worth of t's. I'm going to use half as much, and I get from 0 to pi. If I want to maybe make from sort of the bottom corner, I'll do from pi to 3/4 pi. Oops, not 3/4 pi, sorry. 3/2 pi. There you go. So that's going to give me the bottom corner there, because pi over here is halfway and 3/2 pi is 3/4 of the way to 2 pi. If I'd like, I'll change these back to 0 and 2 pi, get my full circle. What if I want to make an ellipse? Say the one where the horizontal radius is 2 and the vertical radius is 1. I just put a 2 there. That stretches it out. And if I want to make it be 3 times taller vertically, I can put a 3 there. So getting all sorts of ellipses are very easy. What if I want to move them over? Then I would just, again, put in a little translate matrix over here, move it over 1 and down 1. And so I've moved it over 1 and down 1. So now we've done circles, we've done ellipses, we've done lines, we've done parabolas. Finally, I'll just very quickly do hyperbolas. That uses, again, some equations from trigonometry that we haven't studied yet. One of them is called secant, and one of them is called tangent. And since it's not a circle this time, it goes on and on forever. We just need to take a very large section of t's. So this won't go forever, but it will go for a long way. So secant t, tan t gives me this sideways hyperbola, sideways oping hyperbola. It's got a transverse axis, transverse radius of 1. What if I want to go up and down? Then I'll do tan secant, and it changes to one that goes up and down. If I want to change the shape, I just put numbers in front of secant and tangent until I get a shape that's pleasing to me. I hope, and of course we can translate that as well. Hope this has been helpful, and I'll talk to you again soon.